In this video, we're going to go over some of the terms used to describe pedestrian footbridges. So by the end of this video and the next couple sections, you should be able to distinguish between plan, elevation, and section views of construction drawings. Second, you should be able to identify the various components of a suspended bridge, as well as compare and contrast the various design objectives considered in suspended bridge design. So we looked at this earlier in a video, but just wanted to have it up there again. But this is a plan view. This is a bird's eye view that's describing what's going on. It's describing what's going on from the perspective from looking above. So you can see the river direction is denoted on this view. We look downstream, and then we have the left and the right side. So that's where we have the left and right abutment, as well as we're calling out different landmarks. We're seeing that there's a boulder field, an existing path, two of them actually, as well as existing trees. You'll notice that with the existing tree, there's that parentheses TYP. That stands for typical. And that means that other things that look similar to it on the drawing, for example, the rest of the trees, instead of having to call them out every single time, we use tip, and that's just a single call out. And the last element that I want to draw your attention to is the north arrow. All plan views have a north arrow to orient them to where they, as to which direction is north. Similarly, we have elevation views. So here we're looking downstream in this elevation, so this would be called the downstream elevation. And we have left and right abutment, and now we're looking at the bridge from a different perspective. You saw back here, we can't really tell how many cables there are. We just are looking at the deck of the bridge as well as some of the fence across the midspan there. But here we're getting that other view. It's that perpendicular view, and we're able to see where things are on the bridge, be it the number of cables, the walkway cables, and the handrail cables. We could call those out, in addition to the depths of the anchors. Unique to this is that we have soil conditions on one side, which is why we have a gravity anchor beam. Throwing a lot of terminology at you, but just bear with me. A gravity anchor, which we use for soil conditions, and then a drum anchor, and that's the type of anchor that we use in rock conditions. As well as there's a bunch of other information on here that we'll get into more depth later on in the course. So I'm zooming in to the foundation and tiers. So if you can see over here, we're zooming in right here on this section of the bridge to the left tower and foundation. And so as you can see, we're now giving more information in this drawing. We have dimensions, we have the ground line. Now I want to go over some brief overview of some terms so we're all on the same page when we're trying to describe something. So first, we have the center line of the saddle. And this is the center line, a vertical line that doesn't have any physical meaning, but we use it a lot in the design, that goes down, it goes where the cable changes angle over the top of the tower, both for the handrail and the walkway cable. So that's what we call center line of saddle. Next, we have what is called the foundation of the bridge. So the foundation is the first building block that is below the ground, or what we call subgrade, that we're going to build the rest of our structure on. So the foundation is 1 meter tall for a standard design, and it starts 1 meter below the ground level at the front of the foundation. So front of foundation's right here, and we start by going down 1 meter. And depending on the number of tiers that you have, these other building blocks, that determines the size of your foundation. So like I just mentioned, there's a couple other building blocks that we use in our standard bridge designs. These are the tiers. So they look similar to the foundation blocks in this drawing, but here we have 2 tiers, and they're each 1 meter tall, and they get built on top of the foundation. And so why we build these tiers is we want to raise our cables up above to a higher level, so we get more freeboard, which I'll go over in a moment. So that's what the purpose of tiers are. After the tiers, we have the tower. So this is the top element. It's a set of reinforced concrete columns that carry the compressive strength from the cables and get them down into the tiers. Sorry, not the compressive strength, but the compressive load. So that's what the tower is. So all four of these terms we're going to be using a lot as we go through and talk about the geometric layout as well as more advanced bridge design. So now zooming out a little bit, you see where we were looking before. Here was the tower, the foundation, the first tier, and the second tier. But now we're looking at more of the drawing. So if you didn't know what we were looking at before, this is an elevation view, as you can see here. So with this, there's a couple more components I want to talk about. The first is the anchor. So this here we're seeing is a gravity anchor, and it's a reinforced concrete beam that anchors the cables so that way when they get pulled on, they just don't pull right out of the ground or right out of our abutment. So this is where the anchor is, and it's denoted here. You can see anchor detail sheet. If we went to that sheet in the drawing set, we get some more details. We then have what's called the approach ramp or the approach walls. So right now we're just seeing the walls, but this is what we call the approach. And that has different dimensions, but basically it's connecting our anchor to our foundation and tiers and tower. So that's the point of the approach. And this whole thing is what we call an abutment. And it's the whole size, so this would be the left abutment from this view. And because the river's to the right here. And then we have, and typically in suspended bridge designs, we have two abutments, one on the left, one on the right. That's supporting the cables and anchoring them into the ground. So there's all three of those terms together. So I threw a lot of terminology at you, and if you want to get more details about this, as well as the rest of what we're going to be talking about, all stems from the Bridge Design Manual. And this is uploaded to the course as a textbook. We're using the 5th edition of the Bridge Builder Manual, and specifically we'll be looking at Volume 2, which surrounds suspended cable bridges. It'll go both into the design as well as the construction. So lastly, I want to take a moment to discuss some design objectives of what aspects of the bridge what are we even designing for? We know we need to build a bridge to get from one side to the other, but to do that, we could do it a bunch of different ways. So we'll have an assignment relating to the design objectives and more of a discussion, as well as some questions about it. But the 7 design objectives that we use in standard suspended bridge design are first, safety. So that means that the structure is safe. We're able to put as many people on it as we deem, we can put lots of people on it and it will stand up. It'll take wind loads, it'll take snow loads, it'll take earthquake loads, and it'll be safe throughout anything that we throw at it. The second is durability. So that way our structure is safe and it's not only safe, but it's durable and continues to be safe into the future. Serviceability. So this is a design objective that relates to how well does our design achieve the design outcomes that we need. If the primary example in suspended bridge design is if something's too steep, if the cables are too steep and no one can walk up the bridge, it's not serviceable. It's not serving the purpose that it needed. Fourth, maintainability. So we're working in rural communities, typically, that do not have access to advanced construction techniques, advanced tools, and so we want to make sure we design something and build something that is easily maintained into the future. Along with that is constructability. We want to make sure that what we design is easily constructible in the places where we are building these bridges, and oftentimes that means not having access to excavators or having access to certain tools, and because of that, we need it to be easily constructible. Sixth is economic considerations. So we don't want these bridges to be outlandishly expensive, but it's lower on our list because some of these other design objectives take priority. And lastly, aesthetics. Aside from the engineering aesthetics that come with a footbridge, we don't put a whole lot of thought or design objectives into the aesthetics as we might in a custom home or another piece of architecture. So what we talked about just now and what you should be able to do is distinguish between plan, elevation, and section views on suspended bridge construction drawings. You should be able to identify the components of suspended bridges. as well as compare and contrast the various design objectives considered when designing suspended bridges.